Section 3.2, we're going to do numbers 1 through 10 in this video. What postulate or theorem justifies this statement about the diagram? So you need to look at this diagram, notice how the lines are parallel, you have a transversal that makes 8 little angles. How do you know that angle 1 is congruent to angle 5? These are corresponding angles. So this is the corresponding angle postulate. And that has a number as well. Maybe I'll reference the number too. I have my theorem sheet here. Well, it's a postulate, so corresponding angle postulate. Oh, where are we? Corresponding angle postulate is postulate 15. So you could have said that also. Postulate 15. Number 2, angle 4 and angle 6 are supplementary. Those are consecutive interior angles. So when the lines are parallel, that makes them supplementary. That's the consecutive interior angle theorem. And we'll find a number for that. Consecutive interior angles theorem. And the number is not on this theorem sheet. It's in your notes. And I'm not going back to find it. So consecutive interior angle theorem, it's theorem something with numbers. That's why it's always good to remember the name of the theorem instead of the number, because the reference number they give you for that theorem is going to be different depending on which text you look at. So remembering the consecutive interior angle theorem is more important than remembering the number. Number 3, angle 4 and angle 5 are congruent. That's the alternate interior angle theorem. I'm using an abbreviation, alternate interior. These are alternate interior angles, so when the lines are parallel, those angles are congruent. Number 4, angle 2 and angle 7. That's the alternate exterior angle theorem. Those are alternate exterior angles, so when the lines are parallel, those angles are congruent. Again, probably in class we would write the numbers down on this theorem sheet as we go, but remembering alternate exterior angle theorem is more important to me than remembering your numbers for the theorems. Okay, next section we're going to find the measure of angle 1 and angle 2. In all of these diagrams you have 2 parallel lines and you have a transversal. So the parallel lines are indicated by those little marks there. If you don't see those marks, the lines aren't guaranteed to be parallel. And if they're not parallel, you're not going to be able to solve for any of these angle measures. So having those marks there is essential. Find the measure of angle 1. Well, it's going to be the same as that 120 there because they're vertical angles. And notice how angle 2 is going to match that one also because these are alternate interior and these are corresponding. Number 6, we have corresponding angles here. And then we have consecutive interior angles here. Consecutive interior angles add up to 180. They're not necessarily the same. Alternate interior angles are the same. So this is 45 degrees. Now, these angles don't have a relationship that we study, but angles 1 and 2 do. That's a linear pair. We did that last chapter. Angles 1 and 2 add up to 180. So this angle here is 135 degrees. Number 8. Again, angle 1 and the 40-degree angle don't have a relationship. But if you know this 40-degree angle, you know angle 2. It's a linear pair with it. So that's 140 degrees. And if that's 140 degrees, angle 1's 140 degrees. They're corresponding angles. Number 9. Same thing here. These angles don't have a relationship, but these ones do. We'll call that 105 degrees. These are alternate exterior. So they're the same. They're congruent. Last one that we'll look at in this video. Angle 1 and the 110 degree angle are vertical angles. Now, this angle and this angle don't have a relationship that we study, and neither do these ones. So what can you do? Well, you can do a lot of things. The idea is the obtuse angles are 110. Notice how this angle is not obtuse. So if it's not obtuse, it's not going to be 110. It's going to be 70. If you would put the alternate interior angle on here, that would be 110, and then you have a linear pair there.